This video covers lots of integration techniques and integration examples. Here's all the basic derivative and integral rules that you must have learned in Calculus 1 that will be used in this course. Make sure you memorize all these rules. There's more on the next page. Memorize all these rules as well. Derivative and integral rules. And then there's a few more that you may not have seen in Math 1A. We're going to start by learning or deriving these formulas. Y is the derivative of tangent x, natural log of cos x plus c. So we're going to derive these four formulas. Okay. Let's start with the first one. Integral of tangent x dx. There's no function whose derivative is tangent x, so we have to use, let's go ahead and change it into sine x divided by cos x dx. And now we can let cos x equal to u, and that would be negative sine x dx equal to du, or we can say sine x dx is negative du. And that's going to leave us with negative du over u, which is negative natural log of u plus c. Negative natural log of u is cosine x plus c. So that's the integral of tangent x. Okay, memorize this formula. The next one, we have cotangent x dx. Same kind of story. Cotangent x is cos x over sine x dx. So we're going to let, in this case, we're going to let sine x be the u, sine x be the u, and cos x dx will be du in this case. Okay, so we have du over u, which is natural log of u plus c. And in this case, the u was sine x plus c. All right, another example. Integral of secant x dx. There is no function whose derivative is secant x, so it's not one of the elementary ones. What we can do is we have to use a clever technique here. We have to multiply top and bottom with secant x plus tangent x. Secant x plus tangent x dx. Now, we will distribute the secant x in here, and that's going to leave us with secant square x plus secant x tangent x divided by secant x plus tangent x dx. Okay, so we can let, no, sorry, I don't want highlighter. We can let secant x plus tangent x be the u. That will leave us with secant square x plus secant x tangent x equal to du. So this whole top becomes our du. Du divided by u, which is natural log of u, and that's natural log of secant x plus tangent x plus c. So memorize the integral for secant x dx is natural log of secant x plus tangent x plus c. Okay. The next one is cosecant x, integral of cosecant x. So what we're going to do here is we are going to multiply top and bottom with cosecant x plus cotangent x. Okay. Multiply top and bottom with cosecant x plus cotangent x, cosecant x plus cotangent x dx, and go ahead and try the rest. It would turn out to be negative natural log of cosecant x. Use the same technique that we used in the previous problem. Okay, so that's where these four formulas come from, the last four that we saw. All right, more examples. These are really not Calculus 2 problems. They're Calculus 1 problems, but I just did them really quick to refresh your memory, to review, make sure you have enough practice on the integration. Okay, because we will get into some fun integrals in Math 1B. All right, so first problem, we can go ahead and do the integral of pieces. 3x to the 6th over 6 plus 2x minus 5x to the power negative 3 over 2 plus 1 divide with negative 3 over 2 plus 1. And that is x to the 6 divided by 2 plus 2x. Negative 3 halves plus 1 is negative 1 halves. And when I'm dividing with negative 1 halves, I'm actually multiplying with negative 2. So it becomes positive 10 x to the power negative 1 halves plus a c. Okay. Next, example number 2. Is there any function whose derivative is secant square x? Yes, it is tangent x. So it's going to be tangent 3x and then divide with the 3 plus c. You can always check if your work is correct or not. When you take the derivative of this function, you should get that. If you don't, then you don't have your correct answer. Okay, next we are going to look at cosine x over 2. That would be sine x over 2 and then divide with 1/2, which is same thing as multiplying by 2. Don't forget to add a c because this is the general antiderivative. There's many functions whose antiderivative would be that. Okay, e to the power negative 10x dx, that would be e to the power negative 10x divided by negative 10 plus c. The next one, I can do u sub here. I'm going to write that as a perfect square. And then I would let 4x be u. And then 4dx be du. Dx would be 1/4 du. So this entire integral becomes 1/4 can be pulled out, and then we have du on the top, 1 plus u square on the bottom. 1/4 tangent inverse u plus c, which is 1/4 tangent inverse u was 4x plus c. So that would be our integral here. Example number 6, we can write it as x to the power negative 2x dx. Now go ahead and add 1 to the exponent and divide with that new exponent. X to the power negative 2 plus 1 is negative 1, so we're going to divide with negative 1. It would be negative x to the power negative 1 plus c. Okay, example number 7. Square root of t dt, we can write it as t to the power 1/2 dt. Add 1 to the exponent and also divide with that new exponent. So it turns out to be 1/2 plus 1 over 1/2 plus 1. Oh, that's after doing the integration. So t to the power 1/2 plus 1 over 1/2 plus 1, which is 3 over 2. T to the power 3 over 2 divide with the 3 over 2 is same thing as multiplying by 2/3. So it turns out to be 2/3 t to the power 3 over 2 plus c. Next one, we can just do the integral of pieces. So it turns out to be y squared over 2 plus 2y plus c. Okay, 2 theta squared would turn into 2 theta cubed plus theta plus c. So we just did the integral of pieces. The next one, there's no quotient rule for the integrals, but we can definitely split it into 2 fractions. And now x divided by square root of x, we can subtract the exponents. So that would become x to the power 1/2 plus x to the power negative 1/2 dx. And that would turn out to be, after doing integration, 2/3 x to the power 3 over 2 and plus 2 times x to the power 1/2 plus a c. No product rule for integral, so we must multiply the parentheses. So once we multiply the parentheses, I am going to be left with, FOIL these, I would have 6x squared minus 4x plus 3x minus 2 dx. And that is 6x squared minus x minus 2 dx. Combine the like terms, and that's going to turn out to be, once we do the integration, it would be 6x to the third over 3 minus x squared over 2 minus 2x plus a c. Again, simplify, we can divide 6 and 3, and that would be a 2. Okay, 26 secant x tangent x. Is there, 26 is a constant that we can pull out. Is there a function whose derivative is secant x tangent x? Yes, it is secant x. So 26 secant x plus c is going to be my solution there. Theta plus secant square theta. Again, we can do the integral of pieces here. Integral of theta is theta squared over 2. Integral of secant square is tangent theta plus c. Okay, next example. Again, we can do the integral of pieces here. Cosine 3 theta would be sine 3 theta divided by 3. 1/2 is a constant that can be pulled out. Is there a function whose derivative is secant square theta? Yes, so that would be tangent theta over 4. And I must divide with 1/4, which is same thing as multiplying with a 4. And we can simplify that. So write the final answer in the next step, which is sine 3 theta divided by theta minus 2 tangent theta over 4 plus c. Okay. Next problem, example number 15. We have, again, we're going to do integral of pieces. So it's going to turn out to be 6x squared divided by 2 minus 4 e to the power 5 minus 2x divided by negative 2 plus c. And this can be cancelled, and this would actually become a positive 2 now. So final answer is going to be, kind of short on the space, I'll just write in the box, 3x squared plus 2 e to the power 5 minus 2x plus c. Okay. Anti-differentiation of a composite function. So again, some use substitution examples that you must have learned in Math 1A. How do you decide what's going to be your u? This is what tells you that whatever is inside the parentheses is going to be a good candidate for u. Okay. All right. Several examples with the u substitution. So first one, we can let x squared plus 1 be the u, 2x dx be du. Okay. X dx be 1/2 du. No, I did not need to do that because we already have the 2 sitting over there. Okay, so this whole expression turns into u to the 4th du, which turns out to be u to the 5th over 5 plus c. And now u was, plug the u back in terms of x. And there we are. Here's number 2. We have 3x squared and cube root of x cubed plus 1. We can let x cubed plus 1 as u, 3x squared dx be du. Okay, so this entire thing is du, so it's cube root of u, square root of u du. Integral of square root of u is u to the power 1/2 plus 1, which is 3 over 2. And also divide by 3 over 2, which is same thing as multiplying by 2/3. And I'll plug the u back. And that's our integral. Next one, secant square x tangent x dx. So let's go ahead and break this into secant x, tangent x dx. Now I'm going to let secant x be u, let secant x be u, and secant x dx, secant x tangent x dx be du. Secant x tangent x dx, when I do the derivative, dx b du. Okay, so this entire expression actually becomes u du, which is u square over 2 plus c. And now we're going to replace the u by secant square x over 2 plus c. Okay, and let's check out the next example. We have 5 cosine 5x. Again, you can call the 5x as u if you want, but it's also easily done by remembering this is going to be 5 sine 5x. We must divide with the 5 because of the chain rule, plus c. So it's sine 5x plus c. Okay, next example, x times x squared plus 1 to the second power. So again, use substitution here. Use substitution does not always work, but all the ones I'm doing right now, the use substitution does work here. So I'm going to let x squared plus 1 be u, 2x dx be du, and I don't have the 2 in the front, so I can take it to the other side. So this becomes 1/2 can be pulled out in the front, u squared du, which is 1 square u to the third power over 3 plus c, 1/2, and then u was x squared plus 1 to the third power divided by 3 plus c. All right, the next example we have, let x cubed plus 2 be u, 3x squared dx be du. Okay, I don't need the 3x squared. I need the x squared dx because there's no 3 in there. So that would be 1/3 du. This constant 2 can be pulled out. So it's 2 times 1/3, 1/3 from the du, because x squared dx is equal to 1/3 du. So square root of u du. So that's 2/3. U to the power 1/2 plus 1 is 2/3. I'm going to also divide with the 2/3, which is same thing as multiplying by 3/2. Now, you can cancel 2 and 2 and 3 and 3. So it turns out to be u is x cubed plus 2 to the power 2/3 plus c. Okay, the next problem. 2 secant square x tangent x plus 3 dx. Let's see, I can let tangent x plus 3 be the u, secant square x dx will be du. Okay, this 2 can be pulled out in the front, 2 is a constant, so secant square dx is du. I just have u du here, so integral will be u squared over 2 plus c. The 2 and 2 can cancel, and I'm just left with tangent x plus 3 squared plus c. Tangent x plus 3 squared plus c. All right. So next few problems, pause for a minute, give them a try, and evaluate these integrals, and then check back with me. The first one, once I do the integration, it would be sine 2x divided by 2. The next one, I can let the cos x by u, sine x dx will be du. Actually, negative sine x dx will be du, and sine x dx will be negative du. So I'm going to have a negative u to the third du, which is negative u to the fourth over 4 plus c, and that would be negative cosine x to the fourth power divided by 4 plus c. Okay, the next problem, here we are. So let's see. All right, so we can let x to the fifth plus 6 be the u, 5x to the fourth dx will be du. All right, we don't need the 5 over there, so let's take it 1/5 du. That expression becomes 1/5 u to the 9th du. 1/5 u to the 10th over 10 plus a c, which is 1/5, 1 over 50 1 over 50 u to the power 10th plus c. 1 over 50 u to the power 10 plus c. Okay, and now replace the u by whatever we called u in the beginning. I'm running out of the space, so do the extra step. Replace u by whatever we called it in the beginning. Next example, we have x over square root of x plus 1. In this case, we can let x plus 1 be the u, and dx would be equal to du. And if I try to isolate x here, x would be equal to u minus 1. Okay, so this entire expression would become u minus 1 over square root of u du, which is u over square root of u minus 1 over square root of u du. And again, when I subtract the exponents, it's u to the power 1/2 minus u to the power negative 1/2 du. When we integrate u to the power 1/2, that is going to turn out to be add 1 u to the power 3 over 2, 2/3 u to the power 3 over 2, and minus negative 1/2 plus 1 is positive 1/2. So u to the power positive 1/2 divided by positive 1/2, which is same thing as multiplying by 2, plus a c. Now replace the u by whatever we called it in the beginning. Okay, I'm running out of the space, so I'm gonna leave it at this point. The next problem, again, that is a good candidate for u substitution. So what I'm gonna do is, it looks like one of the trig integrals. Remember your trig integrals back to the integration. So remember how the trig integrals or the trig derivatives look like. Here we are. Okay. So anytime you see square root, just remember these formulas, okay? I don't have space to write, so let's look at the example we were going to work on. I'm going to erase the previous one to make some space for this new problem. Okay, that way I have more room. All right, so in this example, what I can do is, I do not want the 9 over there, I want a 1. So I can pull out a 9 from the whole thing and write it as a perfect square. Okay, so I can pull out the 9 from the denominator. 1/9 comes out, and we can write it as 4 over 3x. Okay, so what we're going to do is, we are going to let 4 over 3x be the u, and dx would be equal to 3/4 du. Okay, so back to our example, we have 1/9 du, which is 3/4, and then 1 plus u squared. Okay, but if I simplify, this turns out to be 1/12 tangent inverse of u plus c, which is 1/12 tangent inverse of the u is 4/3 x plus c. Okay, tangent inverse 4/3 x plus c. That's what we call u. All right, the next example we have here, for this one, let's go ahead and pull the 4, square root of 4 out from the square root. Yeah, let's pull out the square root of 4. So I'd be left with square root of 1 minus x over 2 squared dx. So we're going to let x over 2 be the u, dx would be 2 du. So this is 1/2 times 2, and then du over square root of 1 minus u squared. Okay, now let us see what does that turn out to be. 2 and 2 cancels. This is going to be sine inverse u plus c. Now go ahead and plug. We did let u be x over 2, sine inverse x over 2 plus c. Okay. We will look at next several examples in part B of this video.